See, let sin x equal to t, we should find the 0 to 5 by 2 cos x by 1 plus sin square x dx. Then differentiate with respect to x. Sin x derivative is cos x dx equal to dt. See, limits are changes. X equal to 0, then sin 0 equal to 0, x equal to pi by 2, then sin pi by 2, 1. See, here the limits are 0 to 1, cos x dx is dt, 1 plus t square, then we can write tan inverse t. The limits are 0 to 1, tan inverse 1 minus tan inverse 0. Tan inverse 1 is pi by 4 minus 0, we get pi by 4. See, the basics are very very important. Here let sin x equal to t is the most important. Sin x equal to t, derivative with respect to x. Sin x derivative is cos x dx equal to dt. Limits are changes. When x equal to 0, then sin 0, 0. X equal to pi by 2, then sin pi by 2, 1. The limits are 0 to 1, dt by 1 plus t square, tan inverse t. Integration 1 by 1 plus t square is, what is the formula here? Integration 0 to 1, 1 by 1 plus x square dx equal to, we can write tan inverse x formula. See here, what we are discussing here, the limits changes with the limits are very important here. The limits, when x is 0, sin 0, 0, x is pi by 2, sin pi by 2, 1. The formula is very important. Here limits are 0 to 1 important. Tan inverse 1 is pi by 4. Then we get the pi by 4. See, the basics are very very important here. When you are taking sin x equal to t is most important. Shall we go for the next one? See, same formula, same methods are way to do. Sin x dx by 1 plus cos square x. Let cos x equal to t minus sin x dx equal to dt. Limits, x is 0, then cos 0, 1, x is pi by 2, then cos pi by 2, 0. The limits are most important. When x is 0, then cos 0 is 1. X is pi by 2, then cos pi by 2 is 0. See, 0 to 1 to 0 minus dt by 1 plus t square. Tan inverse t, the limits are 1 to 0 minus tan inverse 0 minus tan inverse 1 minus tan inverse 0 is 0, tan inverse 1 is pi by 4. Minus of minus plus pi by 4 is the answer. The let cos x equal to t is very important. Sin x dx equal to dt is, limits are x equal to 0, then cos 0 is 1. X is pi by 2, then cos pi by 2 is 0. Minus integration 1 to 0 dt by 1 plus t square, we can write tan inverse t, 1 to 0 tan inverse z minus tan inverse 1. 0 minus pi by 4 minus or minus plus pi by 4 is the right answer. See, one more method we have to do. This is the definite integrals. Integration 0 to 1 by e power of x plus e power of minus x dx. See children, here e power of x is equal to t, e power of x dx equal to dt. See, dx equal to dt by e power of x. Dx equal to dt, e power of x means what is dt by t. See here, limits x is 0, e power of 0 is 1, x is 1, e power of 1 is e. Integration 1 to e dx equal to dt by t, then e power of x is equal to t, then 1 by t. We can write 1 to e 1 by t, t square plus 1 by t. T get cancelled, dt, then we can write tan inverse t 1 to e, tan inverse e minus tan inverse 1. Clear understandings, children? The values, limits are very important. X equals 0, e power of 0 is 1, x is 1, e power of 1 is e. Like that we have to discuss. Any more doubt is there, children? When here e power of x equal to t, then derivative e power of x dx equal to dt, dx equal to dt by e power of x. See, limits x equals 0, e power of 0 is 1, x equal to 1, e power of 1 is e. 1 to e, limits 0 to 1 is there, 1 to e, dt by t, t plus e power of minus x means e power of x is t means minus is there 1 by t. T into t, t square plus 1 by t, t get cancelled, tan inverse t we can write, then 1 is tan inverse e minus tan inverse 1 is the formulas. Clear understand, children? Shall we go for the next method? Same problems, but methods are changes. The different methods we are following. Different integrals, so many methods are there. We should follow the different methods. See, zero to four, 1 by 1 plus root x dx. Integration 0 to 4, 1 by 1 plus root x dx. See, x equal to t square, let dx equal to 2t dt. Limits. See here children, when your x is taken, limits are changes. X is 0, then t square equal to 0, t equal to 0. X is 4, then t square equal to 4, t is equal to 2. The limits are changes. Integration 0 is there 0, 4 is there t, 2t dt, 1 plus root x means 1 plus t, 2 is common, we are taking the 2 is common, 0 to t, we can write 1 plus t minus 1, plus 1 minus 1 we can write by 1 plus t dt. 2, 0 to 2, 1 dt minus 0 to 2, 1 by 1 plus t dt. 2 into t, 0 to 2 minus log 1 plus t, 0 to 2. 2 minus 0 minus log 2, 1 plus 1 is 2, minus plus log 1 plus 0 log 1. 2 minus log 2 plus log 1. This is the answer. See, any more doubt in this children? Integration 0 to 4, 1 by 1 plus root x dx. Let x equal to t square, dx equal to 2t dt. Limits x equal to 0, then t square equal to 0, t equal to 0. X equal to 4, then t square equal to 4, t is equal to 2. Integration limits are changes 0 to 2, 2t dt. dx equal to 2t dt. Then 1 plus x equal to t square means root x equal to t it will come. Then upside plus 1 minus 1 is there. 1 plus t by 1 plus t 1 dt minus 1 by 1 plus t. That we can apply log 1 plus t. Limits are 0 to 2. Upper limits 2 is there, 2 minus 0. Lower limits are 0. Log 1 plus 2. We can write log 1 plus 2 means here 1 plus 2 is log 3. Log 3. 2 2s are 4 minus 2 log 3 plus 2 log 1. Log 1 equal to 0 if you are applying, then answer it will changes. Next problem, 0 to pi by 2 cos power of 4x sin x dx. See, simple children, here cos x equal to t. Cos x equal to t, sin x dx dt. Limits are changes when x is 0, then t is equal to cos 0, 1. X is pi by 2, then t is equal to cos pi by 2 is equal to 0. Integration 0 is there 1 to 0 minus cos means t power of 4, sin x dx means dt, t power of 5 by 5 minus limits are 1 to 0 minus 0 by 5 minus 1 by 5. Minus minus plus 1 by 5 is the right answer. Clear understanding, children? Clear understanding, children? Cos x equal to t minus sin x dx equal to dt. Limits changes when x equal to 0, then t equal to cos 0 equal to 1. X equal to pi by 2, then t equal to cos pi by 2 equal to 0. Minus 1 to 0, limits are changes, 0 to pi by 2 is there. When 0 is there, cos 0 1, then x pi by 2 is there, t is equal to cos pi by 2 0, 1 to 0, t for of 4. T for of 4 means t for of 5 by 5, 1 to 0, minus of 0 by 5, minus of 1 by 5, minus of minus plus 1 by 5 is the right answer.